So thank you very much, Katie, for being here today. And I'm going to get the right run sheet. We have Katie Collins from Cambridge University. Her talk is titled Treating Human Uncertainty in Human-Machine Teaming. You have the floor, Katie. Thank you so much.
Great. Thank you so much for the introduction. Yes, I'm Katie. I'm a first-year PhD student at the University of Cambridge, working with Umang, Bhatt, and Adrian. And I'm going to talk about some of our recent work and generally our ideas around human uncertainty in teams. Okay, great. And the goal of my talk today, the brief talk, is going to be to motivate, excite, further stimulate ideas around uncertainty in human-machine teams, and specifically thinking about human uncertainty in these teams. And I'm going to use teams quite broadly to cover generally human AI collaboration. I know there was a great question earlier in the workshop about whether teams is the right word. So I think that's a great point to come back to later, but I'm going to use teams a little bit liberally here. So first off, why do we even care about uncertainty? Well, one of the charges of this workshop was to consider human AI collaboration in a changing world. And changing worlds underpin uncertainty. In our world in general, we're not quite sure what the weather is going to be in the future. Certainly with climate change, there's lots of uncertainty there that we still need to make decisions in even high-risk situations, despite this changes in our world and uncertainty there. Doctors need to come up with treatment plans, usually for a patient, despite not always being sure of the diagnosis in order to improve their quality of life. And we don't always know how the market or anything in finance is going to go. Hopefully things don't go in the direction of this curve, but there's certainly lots of uncertainty in many, many areas of our life, yet we still need to make high stakes decisions and act in this uncertain world. Now, what does this mean for teaming? Well, in cases where we have a human and working together with a machine, or machine giving some information to a human to make a decision on some problem, given our world is uncertain and many problems are uncertain, we don't have complete data, as the past speaker just mentioned, we might want a model that we're working with to be able to convey when it's not sure. But what we'll argue here is that we also want to capture cases when the human's not sure. It could be that the model could complement a human better when it has a sense of when the human is unsure, or we can maybe train models even better if we leverage human uncertainty in the training set, as I'll give a case study of in a little bit. But what I'll note is that there hasn't been as much consideration of human uncertainty in these teams. There's been fantastic work in the machine learning space in general of looking at model uncertainty from various angles, of whether models are calibrated, whether we instead want to have models predict sets instead of just a single label to better capture models' uncertainty, how we communicate that uncertainty to stakeholders. Umang and Adrian and many others have great work in this regard. But the human uncertainty is usually left out of this, this picture. In CogSci, there has actually been a fantastic array of work looking at human uncertainty. But usually in all of these cases of studying biases, people's calibration, whether we have Bayesian mental models in our heads, has left out the model. So it's usually just thinking about a human. But what I think would be really exciting, and what Umang, Adrian, and I, and certainly many others are excited to further, is the study of human and machine uncertainty in tandem in teams. And there's been a lot of great work, even just in this past year, and certainly even before, but I'll highlight three that are looking at human uncertainty in teams. And while I think these are on the right direction, they're fantastic works, usually the focus is still on rich machine uncertainty and very coarse-grained human uncertainty, that we're just considering a single scalar measure of human confidence in some decision, where a human would say, I'm guessing, I'm definitely sure, or maybe I'm possibly sure. But what Umang, Adrian, and I think where we should go is that we actually should get richer uncertainty information from people and place a little bit more emphasis on human uncertainty in teams. So I'm going to give one particular case study of work in this space. We particularly focused on the data that we use to train machine learning models on, which isn't necessarily a teaming sense, but I'll get to in a little bit of where we think that this work could go. But generally, we wanted to reconsider the kinds of data that we use to train models, which are typically annotated by humans. So to go from the human to machine in the pipeline. So we looked in particular at images from CFAR10, which is an image data set that is typically used to benchmark large scale or even in small scale machine learning models, and they're low resolution. So there's been great work from folks at Princeton of Josh Peterson and Rory Battleday and Tom Griffiths and many others of looking at individual differences in how people perceive these images. But usually it's always still each annotator is giving their single most likely label in this image. So you might ask an annotator and they think that this image is a cat. But what we argued is that we should actually even be looking at individual annotator uncertainty. Certainly when I would look at this image, I think that it most likely is a cat, but I'm not quite sure. I think that maybe it could also be a dog. Maybe even in some weird setting, it's a frog, if this was perhaps taken from a strange perspective, or maybe even it's a bird or a frog. So what we wanted to look at is whether we can capture this individual annotator uncertainty and use it to train machine learning systems more effectively. And we found that if we do actually use individual annotator uncertainty as the labels to train machine learning systems, particularly in the image classification setting, we actually were able to boost model performance, generalization, calibration, robustness, all these great qualities. And we released this data set as a new set called CFAR10S. But I think that this work highlights first as a very preliminary step in the direction of richer human uncertainty is that it is feasible and exciting to be able to collect beyond just a single confidence scalar from people and use it to train machine learning systems. But back to the question of human-machine teams, here we're just going in a unidirectional way of from humans to the data set used to train models in a supervised setting. But I think it's really interesting to consider how we might use this kind of richer uncertainty to build systems that complement humans, kind of like the work from Brian Wilder and others, what other forms of communication and uncertain communication and feedback we might want to get from people to incorporate into machines. And while there's also other very interesting questions on challenges that come with eliciting and incorporating human uncertainty that, as I showed very briefly on a slide earlier about Coxside, that people have significant biases in the way that we express uncertainty with one another. And certainly if we would then use that with machines, it's also quite costly to elicit rich uncertainty from people. As we found in our work, it took much more time. And generally being a good Bayesian about the way that we treat uncertainty either in humans or models can be expensive and can be hard or possibly even completely intractable to evaluate. So these are really interesting questions of how we might manage these challenges and these costs in when considering uncertainty in teams, which we think is exciting as this would motivate new algorithms, new data annotation schemes, and generally new feedback mechanisms. So to close out, I think that the point that we're trying to make, and again, I know that there's been great work in this space, but I think hopefully we can convey excitement and further stimulate ideas in this space, but that if we want to build effective teams where the human and machine together are better than the human and human or machine and machine alone, we really want to consider uncertainty, not just model uncertainty to help the systems be trustworthy to humans, but also consider human uncertainty. And in the future, possibly consider many humans who are each uncertain, as well as many models that are uncertain, and consider how we might scale these teams effectively for an uncertain world. So if anyone's interested in uncertainty and teaming, I'd love to chat. My email is here, so happy to get in touch or take any questions or discuss now. Thank you.
Thank you very much, Katie.
You can stop
We
my
have time
screen
for
share.
a question. Come on up.
I'd be glad to ask one.
Yeah. Hi, Katie. Thanks for a good talk. It was very quick. But I just wanted to ask a couple of questions in terms of your understanding of uncertainty. But when you were actually exploring through your research uncertainty, were you also looking at how humans understand certainty? So in order to be able to sort of understand, what are the differences, like why would someone be uncertain? Well, we could then actually have a look at the uncertainty component. And the next part of that question was, and it was actually triggered because you were using the word confidence. And I sort of like came up with that in my research when I was looking at trust and understanding that humans, when they trust something, they have a level of certainty, whether it is certain or uncertain. So I just wanted to sort of ask you in terms of like when you're looking at the uncertainty, looking at that certainty component, how does that fit in with the teamings?
Yes. So I guess your question that looking at how we incorporate human uncertainty in evaluating whether people trust machine learning systems when we're thinking about a team?
So yes, absolutely. So when you're looking at the teaming component and the uncertainty, in order to get that teaming improved, then you have to sort of like lower the levels of uncertainty. So how do you do that, and how do you understand that? I guess the way I guess what I'm trying to say is, as a methodology to get to where you want to, are you looking at models of certainty as well, like how humans get, how they understand certainty from a cognitive science component?
Yes. I think that's a great question.
Sorry.
Yes. No worries. I think it was quite broad, but I think that's definitely where we want to go in our work of looking at human uncertainty or human certainty in many different aspects of both how humans evaluate the uncertainty that a model might give them, and how that changes their trust, and how trust could be expressed partly by looking at human confidence. I think would be very interesting. We haven't done that yet, but I think there's lots of different areas to consider uncertainty. And we're certainly trying to, right now I'm trying to go through even more of the cog sci literature in this space, because there's certainly been folks who've done great work and trying to see how we could bring that into machine learning.
Okay. Thank you.
Thank you.
We've got one question from online. If it's a quick one, Bill?
Sure. Can you hear me okay?
Yes, we can.
Okay, Katie, it seems to me that your human uncertainty is a really interesting proposal. My question deals with, I don't know how that's different from algorithmic or machine learning uncertainty, because you're looking at things at an individual or independent data perspective, and not looking at uncertainty in the environment. Does that make sense to you?
I believe so. Yes, I think your question that what we were looking at, or that the example that I shared, was looking at uncertainty in kind of a specific data setting where we usually have an ID assumption. We're not really going after the uncertain world environment itself. Okay. Yes.
Right. Yeah.
Yes.
You're looking at, right. You're not looking at, say, interdependence, which may generate its own levels of uncertainty, how the machine and the human work together. You're looking at uncertainty strictly in the human as if it were a machine.
Yes, that's a great point. That is what we are doing. I don't think, I think our setting is fairly constrained and really first step in terms of eliciting richer uncertainty from people. But I think that definitely where we should go with the work, and hopefully there's more work in that space, is looking at what you were just mentioning of actual uncertainty in the world, rather than just over a very fixed data set that's been scraped from the world, and treating people like models that are expressing their own uncertainty. So there's not really a big difference in the way that we're treating people then, and getting predictions, like we might get soft predictions from a model. But part of our purpose was then to use that to train a model, which hadn't been done to our awareness by getting individual soft labels.
Good answer.
Thanks.
Thank you very much for the excellent questions. And thank you very much, Katie, once again.
Thank you. Thanks for the questions.